Yes, indeed. Yes, indeed. Rackspace Cantina, how's everybody feeling? All right. It's time for our next Tech Talk. So come on down. If you're downstairs and you can hear me, come on upstairs. We got a cool one for you next. We're going to be walking through some lessons learned as we build one of the largest developer clouds. There are two 1,000 node clusters that were built under the OpenStack Innovation Center initiative. And today we got James and Travis who are going to walk us through that. Please give a warm welcome to James and Travis.
Thank you. So today we're going to be talking about the OpenStack Innovation Center. And the OpenStack Innovation Center is a partnership between Intel and Rackspace. We have, as Tony said, established a couple of very large developer clouds that are publicly accessible. And the reason that we're doing this is under the Intel Cloud for All initiative, we want to create and allow tens of thousands of new clouds to thrive. A big piece of that is enabling enterprise use cases. And for enterprise use cases, a big piece of that is enabling scale, is enabling reliability, resiliency. And really the only way to prove that something will work at scale is to test it at scale. What we found with developers is that people didn't really have access to the large amount of scale that it would take to be able to prove out some of these enterprise use cases. And so we decided to stand something up that would be publicly facing and available for the community. And so this cluster is the first of the two clusters is online. It's being managed by Rackspace, and James is going to take us through some of the lessons we've learned getting that underway.
Thank you, Travis. All right, so with a project of this size between two very large companies, one of the things that always happens is things don't go as planned. The Rackspace cluster in Dallas was designed to be a 1,012 node OpenStack private cloud. So all of those nodes running an OpenStack cloud. Well, based on community requests that were coming in, some people wanted access to an OpenStack project provided through an OpenStack cloud, and others wanted pure bare metal access. Now, the statement of work called for bare metal access through Ironic, but there are various issues with Ironic right now that impede us from putting that in a publicly accessible private cloud. So, in the meantime, what we did was create pure bare metal environments that customers VPN into and are presented with all the various networks they need to pixie boot the environment, get access to the out-of-band management network, and a host of routed networks that they can use for whatever their OpenStack offering may require. So what does the Dallas cluster look like right now? How is it broken up? We have 1,012 nodes. There's a lot of different ways we can mix and match this stuff. So in this very colorful diagram, there are 1,012 boxes. Each box represents a server. And starting from the top in the red is CloudOne. So for any of you that have gone through the OSIC governance board process to request access to the cluster and have requested an OpenStack project and you've been accepted, you're working with CloudOne. So that can be accessed at cloudone.osic.org. If you go there right now, you're going to see a Horizon dashboard that if you have credentials, you can log into. If you don't and you want access, you go through the governance process to get access. Next up in the set of squares here is a 242 node cluster that Mirantis is currently using. It is one of the community offerings, and Mirantis has it for an extended period of time, and they're using it for the OpenStack.org performance lab. Next up, we have 132 nodes, which is also another community offering, and that has already been cycled through a few different OSIC community members and vendors, and they run various tests on those platforms, hand it back over to us, and we clean it all up and hand it over to the next person. Next up, we have a 110 node environment, which Rackspace is using for internal testing. And then after that, we have a 66 node environment, which again is another community environment, and it too has seen multiple turnovers because of all the different people requesting access through it. After that, we have a 44 node environment, which is dedicated to the OSIC engineering team, and it's a permanent allocation that they use to get their work done. After that, we have three 22 node environments. One is for the accelerated Ironic development. The issues I mentioned about Ironic previously are being addressed in that cabinet. And when those issues are fixed, they will eventually be merged into CloudOne so we can allocate bare metal using Ironic. The second 22-node allocation is for the Intel bare metal CI team, and the last 22-node allocation is another community allocation that can be allocated out. So arguably one of the most important parts of the Dallas cluster right now is CloudOne. That is a permanently running OpenStack cloud powered by OpenStack Ansible, which Rackspace Private Cloud runs on top of, and it's managed by the Rackspace RPC support team. And I wanted to briefly show a diagram of what that looks like. It may be a little difficult to see over the monitors. And if it goes, so starting from the top, we have external networks, so public internet coming in, or any sort of external network to the environment. Those hit dedicated aggregate network switches that have 320 gigabit cross connects between the two. All of this gear is enterprise grade, very high performance, based on the number of nodes and all the different people requesting access to the cluster. Connected directly to those aggregate switches are F5 load balancers, and those are responsible for managing and load balancing all of the OpenStack services, as well as all the VPN connections into the bare metal environments. So on those F5s are a multitude of networks that are logically separated between each of the environments, so one environment can't talk to the other. Moving down, we go to the top of rack switches, all 10 gigabit networking at the top of rack, and all the servers, each server has 4 connections up to those top of rack switches, with each server getting an aggregate bandwidth of 40 gigabits per second, and those connections are broken up into multiple bonds based on the way OpenStack Ansible does its reference architecture. And going through the different columns here are the different categories of nodes that we have in the environment. And this follows a OpenStack Ansible and Rackspace Private Cloud reference architecture. Starting from the left and moving to the right, we have a 3-node control plane where Galera, Rabbit, Memcache, and all the OpenStack services run. Moving to the right, we have dedicated network nodes. And the reason for that is, in this environment, there's one provider network. So one routable VLAN with a public IP space that is used for floating IPs. And when we give someone an OpenStack project, they are able to connect their Neutron routers to that network so they have access out to the internet. They are not able to connect their VM instances to that network for security reasons and because we only have so many floating IPs. But what they're able to do is then spin up tenant networks that they can attach their instances to, and then those tenant networks connect to the Neutron router, which in turn connects to that provider network for network access out and network access in through floating IPs. And as the environment grows, if we get resource constrained with the software-defined networks, we can simply add more nodes to that column to provide more resources to distribute load across. We have a single logging node to aggregate all the OpenStack services. And then moving on to the compute nodes, we have 132 compute nodes with regular spindle drives. And then there are 2 sets of compute nodes with different SSDs. The first set has Intel's S3500 SSDs. There's 44 of those. And then the other set has Intel's S3700 SSDs, and there are 66 of those. And finally, there are 44 independent center nodes. There are 4 dedicated Swift proxy nodes and 40 Swift object nodes. And then there's the out-of-band management network for Rackspace is used to manage the environment. So now I'm going to pass it over to Travis to talk about who's using CloudOne.
All right, so CloudOne, again, is that large, permanently running OpenStack cloud. And there are a couple of permanent tenants within that cloud. The OpenStack infrastructure team and OSIC each have fairly large quoted long-term residencies inside that cloud. And they're ongoing using that day in, day out for various things. OpenStack Ansible also has some development activity happening in there. And then we also have a number of allocations that are being granted through the OSIC.org request form. So if you have something that could make use of some large amount of quota, being able to run jobs through that cloud, that intake form is available at OSIC.org. You can check it out and participate in that environment. Now, how do we make this better? Looking forward, we've been running this for about 6 months or so now, and we've had some lessons learned. Intel is in the process of deploying another cluster, the Cloud Native Compute Foundation cluster, and we will be taking some of the lessons learned there, as well as the lessons learned from the OpenStack Dallas cluster, to offer up a new cloud that will be coming online in June of this year. And in that cloud, we will be provisioning, I think, more bare metal allocations. We found there's been quite a bit of demand for bare metal, as a lot of the users of the cloud are interested in really day one types of operations, day one tooling that will allow people to stand up new clouds and being able to do that from bare metal all the way up the stack. There's also an interest in having more flexible allocations. So today, because of the way we carved up the initial cloud, there's really a few sizes of allocations available. We should have some more flexibility as we get Ironic introduced into the environment and have the management plane containerized using Cola. So we're very excited to be bringing on some of those changes as we roll out the second set of clouds that are available for people to be using for bare metal or for quoted types of allocations. Should be able to have a bit more flexibility, a bit more velocity, so being able to actually have faster time to productivity and actually being able to test and commit changes, as well as just overall throughput within that environment as a result of some of these changes that we're making. So with that, I think we also have a contest going on. If you noticed downstairs when you walked in, there's a mini cluster available. That's a prize that we're giving away. So if you go to osic.org/contest and submit ideas for ways that could make really big use, and we're encouraging people to think really big, make use of a large amount of capacity in the OSIC cluster, submit your idea, and we will be giving away some of these mini clusters at the developer reception later this week. So with that, any questions?
All right, thanks, guys. Appreciate it. That is some exciting stuff. Hope you all enjoyed that, learned a lot from that. Also, if you haven't already got into that contest, you need to do that. Those mini clusters are very cool. Make sure you sign up. Farouk, you liked that, didn't you? It was good stuff. It was good stuff.